Okay, students, we're looking at theorem 5, and it says if r is greater than 0 is a rational number, then the limit as x approaches infinity of 1 over x to the r is 0. This is actually based on the fact, and we have to remember how y equals 1 over x behaves. So I have my parent function right here, and I know that the shape looks like this. And I just have to acknowledge that as x grows very, very large, the y for all those points approaches 0. And as x grows very, very large negatively, the y also is approaching 0. If you get to your calculator and you happen to graph y equals 1 over x squared, then we're going to have a function that looks like this, but also the limits at infinity and negative infinity are going to be 0 as well. Now, it's funny that it says this is true for all r's that are positive, meaning if I asked you what's the limit as x approaches infinity of 1 over x to the, I don't know, any positive number, 2/5, what would be this limit? And this limit will be 0 as well, because 2/5, as you notice, is a positive number greater than 0. So as long as it's a rational number and it's positive, then this is true. And this is one of those things that we need to remember as a fact, just like the times table. But you may be wondering if the same works with the limit as x approaches negative infinity. And you have to be careful with this when you're approaching negative infinity, because it says this number r should be a rational number such that x to the r is defined for all x. For example, is y equals x to the 4/10 defined? And this is something that you can graph on your graphing calculators, and know that the domain for this is all the real numbers, because I can raise to the power of 4 any single number and then take the 10th root of that. However, if you were to graph y equals x to the 3/2, then we have a little bit of a problem, because if x is negative, let's say x is -3, x cubed will be -27. And remember that having an exponent of 1/2 means I have to take the square root of that. This will be the square root of -27, and you know that does not exist in the real numbers. So this function right here is not defined for all the real numbers. It's only defined for x being positive or 0. So the limit as x approaches negative infinity of 1 over x to the 3/2, it is not going to be 0 anymore, just because x can never approach negative infinity, because x cannot be negative to begin with, so let alone approaching negative infinity. The function is not defined on this side of the graph, so it's pointless to ask for this limit. Okay, it does not exist. Alright, so that's my note on theorem 5.